Hi everyone. I've never come onto stage to music before. That makes me very, very happy. I also can't see a lot of people because the lights are in the way, so I feel very much like a rock star, which was what I was always supposed to be. Anyway, yes, so thank you for all dragging yourself away from the fish and chips to come and hear me talk about the automation breakup. I don't know why they keep letting me come to speak here at CConf, because I spend most of my time trying to convince you all to stop using Selenium WebDriver, but here I am again. So I'm going to be exploring two different questions. The first is that how do we know that the checks that we've created are valuable and useful to us? And then the second question that sort of stems from that is, if our checks are not valuable, how do we go about identifying valuable checks? What I'm going to do is I'm going to share some ideas, some techniques, show a bit of code, maybe even get it running, who knows? But essentially, all of this comes out of a mindset, a namespace that myself and Richard Bradshaw, who's speaking tomorrow morning, called automation in testing. And we believe that in automation in testing, we should use test automation to support our testing. So part of this is this analysis of our checks to see whether or not they're of use to us. So yeah, first question, how do we know if a check is valuable? I thought the best way to kind of demonstrate this, and also I struggle sometimes with talking about full stack tests, end-to-end tests. They kind of mean different things to different people. So what I'm going to do is I'm actually going to demonstrate what I see as the sort of common pattern of tests or checks that are written in WebDriver. So my check is going to focus on a specific risk. It's going to focus on the fact that a user can log into an application. This risk is quite sort of abstract, quite high level, but we'll sort of dig into that a little bit in more detail a little bit later. But yeah, I'm basically written something that focuses on whether or not a user can log into an application. Now, I'm working with an application that I've built called RESTful Booker Platform. That's a sort of free-to-use open source project where you can practice test automation against. There's a version of it on automationintesting.online, but I'm cheating and I'm going to use mine locally because I don't trust conference Wi-Fis. Sorry. Okay, so let's talk very briefly about what this does. So to start off with, we're using WebDriver to navigate to our home page. Once we've got to the home page, it's going to click on an admin link. It's going to find it, click on it, which takes me to a login page. And then I'm going to fill in the username and password, click submit. And then I'm doing just like a final assertion here, just to say, do I see the room listing page? Which means that I've logged in. Now, for those of you who can see the thread.sleeps, please don't panic. They're just here so you can see the script running. This is not something I would normally do. But let's give that a run so we can see what it is that we're actually trying to test. Fingers crossed this works. The demo gods are good to me. Cool, so it loads up the home page, clicks on the admin link, fills the details in, checks that the room listing page is there, and it passes. Lovely, fantastic. So as I say, this is a common pattern, common approach I see to how a lot of us do test automation or automated checking. Now, I want to take a step back, and I actually want to sort of ask that question. Is this check valuable? Is it something that I want to be running regularly? And to help me determine that, in automation and testing, we've created this series of characteristics, like quality characteristics, ways in which we can judge whether or not a check is of value. So the first characteristic is targeted. So I want to ask myself, is this check targeted? So let's bring it back to that risk. The user can log in. That risk is actually quite abstract. It's quite high level. It's very much focused on the flow of being able to log in. It's not necessarily targeted at specific things that occur inside the product. So say, for example, during that user login flow, there's stuff going on in the back end. But I'm actually driving everything through the browser level. So it's not necessarily the most targeted thing, because if I'm doing everything on the UI layer and something happens in the back end, I'm not necessarily going to get the best feedback. And I'll sort of talk about that more in a minute. So the next thing is it reliable? So we want our checks to be non-flaky. We don't want them to be flaky at all. And we want them to be deterministic until the product changes. That's the value there. That's, if a product changes and that check fails, that's sort of triggering us to sort of explore the system to find out more. So if I end up in a situation where my check fails and I roll my eyes and I go, oh, for God's sake, the check's failed for the millionth time, I better go and fix it, I only spend an hour and a half trying to fix it to go, oh, wait, no, the product's broken. The check was fine, it's the product's broken. Or if I use that awful plugin for Jenkins that makes me run the test 3 times and then pass on the 3rd time if the other 2 failed. I'm sorry, if you've got that in your tool set, you need to remove it now. But that sort of stuff says to me, I don't trust my checks. They are not reliable to me. And if I don't trust them, they don't have a lot of value, because they should be there to help me trigger other testing activities. And then we have informative. Is this check that I created informative? So let's go back to that issue with the check not being very targeted. So I'm running running that check. It's interacting with the login form. It clicks submit, and backend's not working for some reason. Now, I can tell you for a fact, because I developed that application, that I did not develop it very well. So when you click that login link and the backend fails, nothing happens. You just get stuck with the login form. That's not necessarily telling me anything about what's going on in the back end. So it's not very informative. So we want to be making sure that we give our robots, our automated checks, a voice. We want them to give us as much detail as possible so that we can get started with our other activities. So whilst it might not be targeted, I could still think about throwing some logs in there, some screenshots, that sort of stuff. But not massively informative. Then is it maintainable? And this tends to be the topic that we talk a lot about in the industry, about making sure that our code is not brittle, that we use things like dry principle, name our methods and our functions well, and the fact is that it's clear, it's readable, it's legible. And I would say that the code that I've created, I've sort of followed the sort of typical page object pattern, half and half. I'd say I think it is maintainable, but it could certainly be improved upon. And then there's finally the Speedy. Now, Speedy is an interesting one because, again, when we talk about speed, we tend to talk about it in the context of how fast do our checks run. Should we parallelize them? Should we throw more resources at them? But speed really should factor in the whole cycle. So Richard and I like to say a failed check is an invitation to explore. And the check that fails is the start of that exploration. It's telling me that something's not right in that part of the product, and I need to go and look over there. Now, imagine that scenario in which the login form's just stuck there. It may take me an hour, 2 hours to actually find where the problem lies in the product. That's just 2 hours of finding the problem before even trying to solve what the issue is. So when we factor that aspect in, the speed is actually quite slow. If they don't have very good feedback, then I can't react very quickly to them. So this makes up for an acronym called TRIMS. We were going to go with STRIM, but we thought that was a bit aggressive and it might, encourage a few consultants to come in with weed whackers or something like that. So it's a nice little gardening joke there for you. So TRIMS, targeted, reliable, informative, maintainable, and speedy. So it's not very targeted. It's kind of reliable. The system's not changing in this demonstration. But it is dealing with a complex system with lots of different things that move and change. If I'm only focused on a specific part of the application, but I have to turn everything else on, those are all things that can contribute to the failing of my check. Is it informative? Nope. Is it maintainable? I'm going to go with yes, but I'm sure you probably will all end up looking at my code at some point and have some things to say. And is it speedy? It's not. So this pattern that we see typically that's created with our automated checks, that we try and do everything all in one go, this sort of big bang approach, full stack check, test everything at the same time. It's not necessarily going to give you the value that you're expecting to get. So if it's not necessarily the right thing for us, how do we go about implementing valuable checks? How do we identify the opportunities for them? And then how do we go about implementing them? Well, this is where task analysis comes in. So task analysis, Richard put me onto task analysis from some work by a chap called Rob Sabarin, who talks about task analysis within the context of testing in general. But we realized that an activity that we were doing by ourselves was a sort of a form of task analysis. So what I'm going to demonstrate is like a model of how we might approach this. Typically, once you've done this a few times, you start to internalize it in your head because you start looking at how the system works throughout the layers and throughout the different components. But for this sort of demonstration, I'm going to show you a visualization of how it works. So what is task analysis? It's the taking an act, a task, a sort of abstract task, and breaking it down to its different parts. So, for example, we could look at the sort of process of making a cup of tea and breaking it down into its different parts. So we've got the section where we're focusing on boiling the water. We've got the section where we put the tea bag into the mug, and if you're wrong, you put sugar into it. You do not put sugar into tea. This should be your main takeaway of this talk. Do not put sugar into your tea. But yeah, we can break down the different actions that we do to make a cup of tea. We also could go even further. We could get quite granular with this. We could look at the point in which we turn on the kettle. What different acts, what different tasks are occurring inside that kettle? So there's always this balance of trying to hit the right level of granularity. You don't want to go into too much detail sometimes because you'll end up with reams and reams and reams of different tasks, which become hard to process. But you don't want to come so abstract that you end up back in that original position that you're in. Also, they add the milk after the hot water's gone in, so that argument's settled as well. Again, the important things to take away is how to make a cup of tea. Okay, so like I said, we created a model to try and sort of represent how this task analysis works in our head. So rather than making a cup of tea, we're thinking about how our products work. We can look at something like that successful login flow. Like, what did that user do? What actually occurred in the system? And we can start mapping it out. So there's a lot to sort of capture in this model here. First of all, I should talk about the bit on the left-hand side. Is it my left? Your left? Yeah, your left. But on the left-hand side, there's an act that we would do before this, or a couple of different exercises that we would run before this. If we're to create valuable automated checks, if we are to be strategic with our automation, we need to understand how our systems work. We need to understand the testability of these applications as well. We need to explore that information, gather it all together, and try and make sense of it. And we could do things like modeling to help model the system architecture, to take like a snapshot to see how this system works, how these different pieces connect to one another. So from those acts, I've resulted in these 4 blue squares on the left-hand side. And they each represent a different component part of the application that I ran that test against earlier. So we have the UI, which is the stuff in the browser that the user can see. We have the JavaScript. And we've added that in because this application uses React. So React is doing quite a lot of the heavy lifting in terms of building the visual components. We then have the API. So we're moving to the back end. We've got a web API. But then inside that web API, we have service code. Because the web API, I like to sort of sometimes think of them as like the bouncer. You can come in with those shoes, you can't come in with those shoes. That sets the parameters of what information can come in and what information can come out. But when that API is triggered, it's actually going to defer some of that work to a service layer. This is why we have the concept of like controllers and service layers within our APIs. The controller triggers the service code. So these are the main component parts of my tech stack within the context of the successful login flow. If I had multiple APIs, I might list multiple APIs down that left-hand side. If I had databases, I'd list those. So if you were to do this, you have to spend some time understanding how your products work and how they hang together before we could capture this. Then you'll notice there's the blue lines in between, and these are the seams, the layers, the interfaces in which data, information, triggers flow across. So a common one that we all tend to know about is HTTP, because that's something that happens over the network. But we could have ones in which, when we press a button in the browser, that triggers something in JavaScript. There's an unseen layer or an unseen divide there between how we trigger something in the DOM and how that will actually fire some code off for us. And then the same like on the Java side. A lot of the unit checking stuff we do, we're trying to emulate how Java objects trigger other Java objects or methods. Again, it doesn't really matter what language this is in. So the fact is that we have these small individual parts that talk to each other. And then finally at the top is the user. So there is an interface between the person's eyes and the screen they're looking at as well. So a lot of information to take in there, but what we can do once we have this all in place is that we can then start to map how the actual flow works in our system of login. So we start with an initial state. So that little green dot there is just telling me some initial states that I want to be in, because I don't necessarily want to capture everything within this task analysis, but you could do, and you'll be surprised how long they get. So this was more of a stylistic choice that I was trying to fit everything into one slide. It was getting quite compressed at one point. But yeah, the green dot talks about sort of initial state. So single page app code loaded into browser. Poorly worded, but really it should be the home page is loaded. And then the current state is I'm not logged in. So from those points, let's take those different triggers. Let's take those different steps through the login flow. So first of all, the user is going to click that login link or that admin link at the bottom of the page, which is really hard to find, and I should do a better job of making that more visible, but there we go. But you click on that link, and that actually triggers React. So React does some magic, I think. I think that's how React works. It's magic, isn't it? It's like little pixie elves in your... Yeah, good. I'm getting some nods. It's definitely magic. It's been confirmed. But yes, I click that link, and that triggers React to build the component login page. So that's building all the HTML, running a bunch of other functions if it needs to run them. And that presents us with a login form. So the user now interacts with that login form, fills it in, hopefully puts the right credentials in. This application is 2-3 years old, and I still put the wrong credentials in. It's quite shocking. And submits the credentials, admin, and password, because this application is also very super secure. Click Submit. Submit triggers some JavaScript. JavaScript sends an HTTP request with the credentials to the auth API. Auth API says, oh, thank you for those details, parses them, turns them into a Java object that can then be consumed by the service layer. So the service layer is triggered off. The function takes, it's admin password. They're the correct credentials. And I'm going to create you a token that you're going to use later on in the application. So we've gone all the way down. We've got to bubble back up now. So once the API is complete, got that token created, it's going to send a response back with that token inside it, sending an HTTP response back, which JavaScript goes, hey, thank you, I got a token. That's fantastic. I'm going to flag myself as logged in. And being flagged as logged in causes some other React magic to occur, and that causes the room component to render. And once that room component is rendered, the user can see the room. It's quite a bit to cover. So when I created this task analysis, this was the simplest thing I could do. If you were to carry out this task analysis on some of your systems, it would be much more up and down, lots more things happening. Now let's go back to that original check that we were running. That's supposed to be checking for all those different points, those different triggers that occur. So as I say, if something like check credentials, create token fails, it's going to take me a while to work out what's actually going on and react to it. But by mapping out the different activities, the different triggers that occur, we can then actually start to dig into our system more. So we can now start thinking about risk again. So rather than that big abstract risk, which is the user can log in, we can start targeting those individual dots. We can start thinking, well, what risks could affect those specific dots? And that's where we start to identify valuable checks. And what I want to do is I want to demonstrate 4 different checks I could take from this visualization, and then I'll show you how they're implemented, and we'll give them a run, and fingers crossed the internet's still holding up. Okay, so you notice there's a bit of change now to this model. First of all, I'm thinking about a very specific risk now. I'm not thinking about the whole successful login flow. I'm talking about one specific risk that could affect the login flow. And that would be something like the login form is not rendered correctly. So all I care about is that when I'm presented that login form as a user that I can see in the browser, it's all correct and it works in a way that allows me to sort of interact with it, or at least look visually appealing. So from there, I'm thinking about a visual check. And the reason why I'm thinking about a visual check is you'll notice now I've added in 2 new icons. We've got a robot and a little magnifying glass. So when we automate, we are replacing that person or that thing that is interacting with that part of the system with some sort of robot. So when we use Selenium WebDriver, we're typically removing the user out of that and getting that tool to interact with the browser instead. So we put this little robot in there because that's impersonating the user. We created a new actor. So that robot is going to do the absolute sort of bare minimum here. It's just going to open up the login page to trigger off that build login page component. And then that's going to give us a rendered form view in the browser. And then the little magnifying glass is at the top there is because I'm focused on how the user would interact with the system, I probably want to assert on that level as well. So a user has eyes, they're going to look at it. So this is where something like visual testing or visual checking can come in. So, and one other thing as well I should probably add before I start showing you the toys is that notice how all those other points are grayed out. And that's because I'm focused on one specific area of the application. I don't necessarily need the rest of the application up and running. I don't necessarily need the back end up and running. I could, we could talk about things like mocking and dependency, but for now, all I care about is that this specific area is tested, and the rest of it we can deal with at a later date. And we'll sort of cover that as we start to build all these different checks up. So I'm just focused on, spoilers. I'm just focused on how the page renders. So let's look at our second example. For this, I'm using Applitools because it's something I've used commonly in the past. I'm not trying to endorse any specific tools and stuff. These are just things that I feel comfortable with. The point is that the point on which I was trying to build that check, the area, the risk that I'm focused on, helps dictate which tools I want to use. So I chose Applitools. The WebDriver script, or the WebDriver code, Selenium WebDriver code, there is just that line. I just need to open that page because the application is all up and running. So I just focus on that page, and then the rest of it is Applitools doing its, definitely doing magic, to do some screenshot comparisons. Okay, so let's give that a run. Here we go. So we're still working in that space where we're interacting with the browser, but I'm not necessarily manipulating lots of form fields or adding in any data or doing any state setup or anything. All I'm doing here is loading that page up and doing a screenshot comparison. So we can see that it's failed. That's good. I was hoping for that. This is all going very well. Now, if we go back to my dashboard in Applitools, we can see that we have a unresolved test. And in here, if I click the little highlight buttons, because it might be quite hard to see out the back. See if I can zoom in a little bit. But we can see these little marks here that show me that there has been some changes between the different visual comparisons. So that doesn't necessarily tell me how the API is behaving. It doesn't tell me whether or not the front end is talking to the back end, potentially. Depends which APIs you're interacting with. I'm just focused specifically on how the form is rendered. So that brings us to our next one. So this time we're going to go down a layer. Well, we're going to go down into the back end. So now I'm focused on a risk that the auth API processes requests properly and sends the right response back. And this is what we sort of typically see with API checking. Now, notice the robot and the magnifying glass have moved down to that HTTP layer. So the actor or the person or the thing I'm impersonating has changed. It's no longer the user, it's actually JavaScript, because JavaScript is normally responsible for sending that HTTP request. So I'm going to build a tool that impersonates JavaScript by sending an HTTP request. And again, I'm going to send something via the HTTP layer. Something else is going to bubble up, and that's where I'm going to do my assertion. That's where my magnifying glass is going to be. It's going to be what comes out from that layer as well. So let's see that one in action as well. Oh, it's quiet. Okay, so this time I'm using a tool called Rest Assured. Again, no preference, just it was something that I could quickly and easily put together to show how I would implement this check. So the first thing I'm doing is I'm creating that payload with that super secure username and password. And then I'm using Rest Assured to set content type, add that payload in, and then I'm sending a post request to the login endpoint. And then that stores me some details back in a response object. And then I'm just going to say, did I get a status code of 200? And does it also contain the string token in there? Normally I'd do something a bit more sophisticated with this to make sure that the actual payload matches what I would expect. But I was feeling a little lazy and it was late a couple of nights ago writing this code up. So, don't crucify me for the bad assertion. The point here is now that when I run this, no UI, no browser setup, nothing, just focused specifically on the API. So for those two examples, I've created checks that are much more targeted. So if one of those fails, I know now that specifically something's either failed in the front end or something's failed in the back end. There's an acronym I like to use, which is TUTU, where you ask the question, are you testing the UI or testing through the UI? Because if you're testing risks, if you're interested in testing or checking risks that exist in the back end and you're doing it through the UI, you're adding complexity in there. Which may affect reliability. And you're also not necessarily making them the most informative. With these two checks that I have now, they are much more targeted. They're more reliable because I don't have complex bits of system being set up. They're informative because if they fail, I know clearly where to look. They're maintainable as well, because what we're going to notice as we go through these examples as well is the amount of code that needs to be written is getting less and less. Less code should equal more maintainable, but not always the case. Depends how well you've abstracted your awful code. But the key is they're speedy, because if these do fail, I know specifically what has failed, and I know how to react to that. I can start focusing on the problem straight away. So I'm going to wrap this up with 2 more examples where we're going even further. We're going into the unit level. So we're starting to identify the potential for unit checks. So for this one, I'm just focused on whether or not the token is created correctly. And this time, I'm actually the actor, or the thing I'm simulating is the service layer of my API. That's the controller layer of the API. The controller typically triggers the service code. But what I'm going to do is I'm going to use something like JUnit to create a unit check that's going to trigger that process for me. So I'll go back to our code again. And we're down to 4 lines of code. Let's see if we can get this lower. But with this one, we're just instantiating an object from the class that it handles the whole checking of the credentials and generating the token. So we can see here, decide on token generation. We're setting in those awful credentials. And it returns us a decision object. And I'm just asserting that it has a result of true, so true, it's valid credentials, and that it also includes a token that I can send later on. So let's give that a run as well. So that took 10 milliseconds to run. So fast to run, fast to quickly react to as well. If that fails, I know specifically that method has failed, or something within that method has failed, and I can react to that. And what we've done here is we've sort of divin? I never know what the right word is for that. We went lower into the application. We went further into the back end. But we can apply the same sort of rules to the front end as well. So as I said, we're using React. React is a highly testable application, well, code base, API, SDK. But it's highly testable. So as we saw demonstrated in the accessibility talk that we saw this morning, if some of you saw that, we can actually isolate these React components. We can render them headlessly, and we can then view the output of that as if it was HTML and make some decisions here. So if I'd have had time, I would have loved to have put that accessibility example in here about how it would work in the wider strategy. But for now, my risk is that I just want to check the login HTML is correct. So when we were looking at it on the render level, we had complexity around not just the HTML, but the styling as well. Whereas this time, I'm just like, is the semantic structure of the HTML correct? So this is a unit check, but this is something that's done in the UI layer. So for our final check, let's move over to here. Whoa, I got it down to 2 lines of code. I think I would be taking the mick if I got it down to 1 line of code. I think you'd probably all chase me out of here with pitchforks and flames or something like that. But all I'm doing here is, admittedly, some setup is in a different file that's being imported in. But essentially what I'm doing is I'm using a tool called Enzyme, and Jest is my runner. I'm using Enzyme, so I import my React component. I use Enzyme to load the component in and load it up. Well, it loads it into a small little DOM, which triggers that whole React process to turn it into HTML. That HTML is dumped into my login component. And then I'm using an assertion here where I'm saying expect the HTML to match a previously accepted snapshot of that HTML. So it's similar to what we saw in Applitools, but this time we're doing it on in terms of sort of some code or some stringed data. So let's give that final one a run. I don't know how well we're going to be able to see this because it's a dark screen. Oh, thank you, lights. Oh, making it all much more intimate. Okay, so there we go. That's our final check there. So now we've seen it checking that the HTML is correct, and just to sort of add a bit to that, because that's just basically a screen rendering some stuff. If we go to snapshots, we can actually see the HTML here on the right-hand side. That's all been captured. OK. We've taken one big check, and we've broken it out into 4 small ones. And some of you might have that, what I like to call a sort of software tester Speedy sense. The fact is that if we're focusing on specific areas, we're ignoring other areas. And we need to be wary of that. And that's good. That's good to have that Speedy sense, because that's telling you that there's potential checks that could be identified and created in other parts of the application that are still targeted on specific areas. But what we can do is we can actually combine all of these things to create a collage of different checks. And we can actually create a build pipeline, or just a batch script or a bash script that just runs these different checks in a specific order. And what this does is this can create a chain of trust. So if I'm to run my API check to make sure that the request and the response is behaving correctly, that's not necessarily the most targeted thing if something fails within the service layer. But if I've run I execute a previous run of unit checks that tell me that the service layer is behaving properly in its individual parts, when I come to running the API check and it fails, I've already got some information there that says to me, well, it's not necessarily how the code's written, it's maybe how the code interacts with other component parts. Maybe there's some misconfiguration in the integration, or maybe the app isn't up. And we can do the same thing on the JavaScript layer. So I could say, is the HTML rendered correctly? I can run that check. Yep, brilliant. But the visual check failed. Well, it's not necessarily that the HTML is wrong, it's that maybe the styling's wrong. So we're creating targeted, informative checks that can make us speedy because we can react to them quickly, because they're actually building on one another in terms of their trust. Which means I could bring that first original check back into the mix, and that could become a full stack smoke check. So rather than it being something that says the user logs in successfully, the risk of that original check that I created is the front end can talk to the back end. And that's all I care about. But I'd only ever have one of them because I just need to make sure that the UI can talk to that auth API. So to wrap up, I encourage you to all go back and ask yourself, are your checks trims? Are they targeted, reliable, informative, maintainable, speedy? If they're not, then try this task analysis technique. Try and understand how your products work. What are the different component parts? How do they connect to one another? If you can't answer that because it turns out your app is really complex or no one wants to talk to you, you have bigger problems than whether or not you can design good checks. You have organizational things that you need to get to therapy about quickly. But yeah, learn about your systems, then put them in this sort of grid-based system or model them in some way. Draw your finger around the model and try and understand how this user flow hits all these different points. Once you have these points, use that as an opportunity to identify targeted checks. The fact that you've chosen these points will dictate to you or lead you towards specific toolings, like it has for me, but it will also result in much more valuable checks. And then finally, once you've started to create all these different checks, I like to think that a successful regression checking strategy for me is not one big monolithic tool, but lots of different little tools that are all connected to one another, all prodding and probing that application in different ways. But all of them come together to give me the full picture, and they rely on one another to give us feedback. So that's it. I have 40 seconds left, which is 40 seconds more than I had last night, so I'm happy with that. I will be at the office thing that I can't remember what it's called, but I'll be there if you want to answer any of your questions. But if you want to learn more about automation in testing, check out automationintesting.com. And examples of the code that I have here, they exist within the RESTful Booker platform repo. I encourage you to have a look at them. There's much more in there as well. It's a rich bed of stuff to tell me that I'm doing wrong. But thank you. Cheers.
Thank you, Mark.